Your brain is a marvelous thing. The most powerful computers on the face of this earth, the ones that fill up whole warehouses, cannot keep up with the awesome power of your 1.5 kilograms of squishy material sitting inside your skull. But how the brain does all of these amazing things like create thoughts, emotions, intelligence, or even consciousness was for a long period of time uncharted territory because scientists didn't have the methods to look inside a brain in action. Now, if we could look inside, the benefits would be tremendous. Not only could we create computers that are much better or develop new treatments for mental diseases, but we could start answering very fundamental questions about who we are and what makes us human. Now, scientists had to wait until 1992 for a new method to be invented that would allow them to look inside a brain while it performs a certain task. That method is called functional magnetic resonance imaging, or fMRI for short, and it has allowed us to learn about what every single brain area does. Now let me try to explain to you how this very important method works. Step inside an fMRI machine, an incredible feat of engineering. The largest part of the scanner is a very powerful magnet that creates a magnetic field 10,000 times stronger than the Earth's magnetic field. Today we're going to take a look at how this incredible machine actually works and how it has enabled us to see which brain areas are more active. Now, what does it mean when a brain area is more active? Well, the brain is made up of neurons, and these communicate with each other using electric signals. Now, a brain area is more active when the neurons inside that brain area start sending more signals than before. For example, if I start moving my arm and I see a brain area that lights up or becomes more active, then I know that that brain area probably is responsible for my arm movement. Now, it is possible to measure electric signals directly from the scalp, but the problem is finding the exact origin of that signal because all brain areas are sending signals all the time and overlaying with the signal that you actually want to measure. Now, fMRI can solve that problem, but it involves three things. Neurons have a pretty nifty trick up their sleeve. When they become more active, they need more oxygen, which they get from red blood cells. So what they do is they actually widen the blood vessels surrounding them in order to attract more oxygenated blood. Now that means when a neuron becomes more active, the oxygen concentration in the blood increases there as well. Our bodies are mainly made up of water, and each water molecule has something called a spin, which gives it its magnetic property. Now, you know how a compass always points to the north because it wants to realign with the Earth's magnetic field? Well, you can do the same thing with water molecules, but you need a much stronger magnet, like the one from an fMRI machine, to achieve something like that. Now, suppose you have them aligned in your strong magnetic field, like that, and you add a little bit of energy in form of radio waves, you can actually force them into yet another alignment, something like this. Now, if you stop sending radio waves, they will start to be attracted to the strong magnetic field and wobble back to it. Now, as they do that, they send radio waves back to you. Now, in the beginning, you can see that they're very much aligned to each other and that they send radio waves at the same time. So that means the radio waves can add up to give you a very strong signal. But with time, they start to desynchronize and send radio waves at different points in time, which means the radio waves cannot add up and the signal that you measure weakens. That's like a team of tug-of-war pulling on a rope. They all have to pull at the same time so that their forces add up. Now, with time, as the water molecules desynchronize, your signal becomes weaker and weaker and weaker. And with that, we're now ready for the final piece of the puzzle. Magnetic fields, like this one here, can have small disturbances in them that cause water molecules to desynchronize faster. Think of two coins spinning on your desk and one of them constantly bumping into other objects. Well, that one will stop spinning earlier, right? Well, the same goes for water molecules. Turns out that deoxygenated blood causes such disturbances, while oxygenated blood doesn't. So now we can put everything together. A brain area becomes more active, causes the blood vessels to widen, meaning more oxygenated blood flowing towards it. That means less magnetic field disturbances, the spins synchronizing for a longer period of time, and the signal that we want to measure staying for a longer period of time. So in other words, what fMRI is doing, it looks at a particular brain area and repeatedly measures how long the signal stays. And when that signal starts staying longer, we know there's more oxygen, and we know that that brain area is becoming more active. Just 20 years ago, we hardly knew anything about the brain, but with fMRI, we were able to learn so much about what every single brain area is responsible for. Scientists are already looking at the next frontier in brain research. The Human Connectome project is an example where scientists are currently looking into how the brain areas are connected to each other and how they work together depending on the task. The goal is to create a map of all connections inside the brain. Such brain maps would have tremendous value. We may one day be able to diagnose depression or schizophrenia by just looking at how the brain map of patients differs from healthy people. A brain map of such kind could also help explain how our tiny brain is capable of so many amazing things. Computer and brain scientists are already working together to build new powerful computers that mimic the human brain. Now, all of these advancements and many more were largely made possible by fMRI. But what I always find absolutely fascinating is that there is something out there that has the curiosity and the ability to look at itself to learn about how it works. And there's nothing else in the universe that can do that. And that blows my mind.